I'm Anil Kumar. Welcome to my series on vectors. Let me thank all my subscribers and viewers for participating actively and posting questions. Now, in this particular video, I will be answering questions from my student Anna, who wants to understand basic concepts of dot product. I hope these solutions will also help many of other viewers. We have 7 questions in this video to discuss. Question number 1 is explain if the following are always true. So the word always is kind of important to understand. Explain if the following are always true. A dot B equals to B dot A. B is A dot B dot C is not meaningful. C is if A dot B equals to 0, then the two vectors are perpendicular. D. A dot B equals to A dot C implies that vectors B and C are equal. You can actually pause the video, copy these questions, answer, and then look into my suggestions. Question number 2 is prove the identity sum of two vectors square plus difference of these two vectors square is equal to twice magnitude square of A plus twice magnitude square of B. Question number 3. Vector A, so these are vectors, vector A and B, right? Vector A equals to k minus 2, 3, and vector B equals to 2, 2k minus 6 and 6. Find k if the vectors A and B are perpendicular, are in the same direction, or are in the opposite direction. So I hope you have copied these 3 questions. Let's move on to the next 4. Question number 4 is if magnitude of A plus B is equal to square root of 5 over 2, find dot product of 3A minus B times A plus B, right? Question number 5. Adjacent sides of a parallelogram are vector A equals to 6, 1 and vector B equals to minus 1, 3. So these two vectors define adjacent sides of a parallelogram. Determine the angle between the diagonals of this parallelogram. Correct? Question number 6. Find a unit vector. Find a unit vector perpendicular to vectors A, which is 3, minus 2, 7, and B, which is 2, minus 1, 2. Question number 7. The rectangle ABCD has vertices at A, minus 1, 2, 3, B, 2, 6, minus 9, and D, 3Q, 8. Determine angle between two diagonals. So I'd like you to answer these questions and then look into my suggestions. Let's begin with question number 1. That will also give me an opportunity to describe what dot product is. Question number 1 is explain if the following are always true. First one, A dot B equals to B dot A. Now let's understand what is the dot product. A dot B is equal to magnitude of A times magnitude of B times cos of angle between them. So let's say theta is the angle between them. Then dot product of A and B is magnitude of A times magnitude of B times cos theta. Now when we say angle theta, we are always using these vectors as tail to tail, and then the angle is this angle between them, right? So that is how we define the angle when the vectors are placed tail to tail, correct? Now if I interchange, if I write B dot A, if I write B dot A, even then the equation remains same. Do you see that? Magnitude of A times magnitude of B times cos of same angle theta. Now this is always true, and therefore we can write this as this is always true. B. A dot B dot C is not meaningful. So we know A is true. Now let's talk about B. We are saying vector A dot vector B dot vector C. Now, if I do A dot B, what do I get? Now, A dot B is always a scalar. You can see that it is a vector dot product. A and B should be vectors. Now we have a scalar and then dot with a vector. This is a vector. Does it make sense? No. We cannot have dot product between scalar and vector, right? So that is not valid. So it is not valid. So this statement is not meaningful is also true. It is always true, right? We do have a scalar multiple, but not dot product like this. Okay. Now let's look into part C. Part C is, if A dot B equals to 0, then the two vectors are perpendicular. How about this? Is it true? Is it always true? Well, there is a condition, and that is, how about if vector A is equals to 0 vector? In that case, A dot B will be 0, right? Or if B is a 0 vector, in that case, also dot product will be 0, and they are not perpendicular. You get an idea, right? So this statement is false. This is not always true. So here, it is only true if both are non-zero vectors, right? So let me make a note here. A dot B equals to 0, then the two vectors are perpendicular if A and B are non-zero vectors. That is important to understand, right? Now, part D is kind of most important in this set. Now, what we are trying to say here is that if A dot B equals to A dot C, that implies that B and C are equal. Now, this statement, let's look into this. Let us say we have A and B vectors here. What is A dot B? Now, geometrically, I could represent A dot B as, see, A dot B is A times B cos theta, correct? Now, if I drop a perpendicular here, then let's say this point is O and this point is N, then what is ON? ON is B cos theta. ON is B cos theta. Do you see that? So the projection of this vector on A is B cos theta, correct? So that is the projection. So A magnitude is fixed, which is shown by the line, let us say OA, and this is OB. In that case, you can see that magnitude of A is OA, magnitude of B times cos theta is ON. So I could write A dot B as equal to, from this figure, OA, right? So magnitude OA times magnitude ON, right? Because B cos theta is ON, since B cos theta, magnitude of B cos theta is equals to ON, right? That is the adjacent side of a right triangle. Now I could have a scenario where there is another vector C which is kind of like this. Do you see that? I mean, kind of like this. Do you see that? Now the angle is different. Let's say angle is phi. However, the projection of C is still the same as ON. Even then, the dot product is going to be exactly same. ON times OA. You get an idea, right? So all these vectors, I mean, kind of like this, where the projection is same as ON will give you same dot product. So therefore, B is not equal to C, as you can clearly see here, right? So I hope that is absolutely clear. So projection of a vector is a huge application of dot product, which we'll take up in the next video. But I hope this point is absolutely clear. And with that, we understand what dot product is. So a dot product results into a scalar quantity. So whenever you do this dot product, we get a scalar quantity, right? Since dot product is scalar, scalar dot product C is not valid because dot product is between two vectors, right? A dot B is equals to 0, and if both or none of them is 0, in that case they are perpendicular. But if they are 0, one of them either, right, with that condition, then they are not perpendicular. And if A dot B is equals to A dot C, it does not imply that B and C are equal. As you can see, they are different. Well, their projection on A will be same, which we are going to learn in the next chapter. So I hope that's clear. Let's move on to question number 2. Question number 2. Prove the identity magnitude of A plus B whole square plus magnitude of A minus B whole square equals to twice magnitude of A plus twice magnitude of B square, both squares, right? Now, Anna, this is an excellent question. We'll use the property of dot product, which is that if I have a vector A, then the magnitude square of a vector is equal to the dot product of vector with itself. So that is a property of dot product. As you can see, A dot A basically will be magnitude of A times magnitude of A times cos of angle between them. So cos of 0. 0 will be the angle between them, 0 degrees. So that gives you magnitude of A whole square. So this is the property which we are going to use to prove this identity, right? So let's begin. So we have on the left side magnitude of A plus B whole square plus magnitude of A minus B whole square. Now magnitude of A plus B whole square also means A plus B dot A plus B, right? Using this particular property, that dot product of vector by itself is square of its magnitude, right? So we could write magnitude of A plus B whole square as dot product of A plus B by itself. Similarly, we could write this as A minus B dot A minus B. Is that clear? Right. So that is how we could write the left side. Now, let us expand using the distributive property. So A dot A will give us magnitude of A square, and then we have plus A dot B, then B dot A, and then we have magnitude of B square, right? Let's do with the second part, which is A dot A, which is magnitude of A square, A dot B with a negative sign, and minus B dot A, and this gives us minus, and minus makes it plus magnitude of B square, right? Now, so we have A square and A square magnitudes, they combine. So we are going to combine these two terms I'm sorry, this one, right? So that gives you 2a square magnitude. Now I'll combine the b square parts. Let's combine these two. So that gives us 2b square magnitude. Now a dot b and b dot a commutative property, they are same, correct? Now, but they cancel out also. So we have here a dot b cancels with minus a dot b, and b dot a cancels with b dot a. We have already taken care of these two, so that's what we see, and that is equal to the right side, right? And therefore we can say that the magnitudes of square of their sum and difference is equals to twice magnitude square of their sum, right? Like this, 2 times. So that is how you could prove it. So I hope it is absolutely clear, right? Now let's move on to the next question, which is if vector A is equal to k minus 2, 3 and vector B equals to 2, 2k minus 6, 6, find k if vectors A and B are, so 3 different conditions. A is perpendicular, so let's do perpendicular. So we are looking for vector A being perpendicular to vector B. Now they are perpendicular if dot product is 0, right? So that means we could look for vector A dot vector B equals to 0. Now what is A dot B? We could say 0 is equals to A is k minus 2, 3 dot, and B is 2, 2k minus 6, 6. So from here we could write 0 is equal to k times 2 is 2k minus 2 times this, let's write minus 2, we have 2k minus 6, and 3 times 6 is 18, so plus 18. So what we get here is this could be written as minus 2k minus 4k, minus minus becomes plus 12 plus 18, or we have 0 equals to minus 2k, and that is 10 and 30 plus 30. So we could write this as 2k equals to 30, which implies that k equals to 30 over 2, which is 15, right? So for perpendicular, we get k equals to 15, right? Now let's do part B, which is are in the same direction. When we say they are in the same direction, we mean they are scalar multiple. In the first case, we said A dot B should be equal to 0. So scalar multiple means that vector A, which is k minus 2, 3, should be equal to some scalar times, we are using lambda, 2k minus 6, 6. Let's find the value of lambda. So we get actually 3 equations from here. First equation is k should be equal to, their components should be same, equals to lambda times 2, right, or 2 lambda. Second is minus 2 equals to 2k lambda. Let's write down lambda times 2k minus 6 for the time being. And the third one is 3 equals to 6 lambda. Now, from equation 3, we can actually get the value of lambda. So from this equation, what do we get? We get lambda equals to 3 divided by 6, which is half. Now once we know this scalar, which is half, we can substitute this value back into our first equation. So if we do that, what do we get k as? So that gives us k equals to lambda is half for us. We'll write half times 2, which is 1. So the value of k in this particular case becomes 1. Now if I substitute k equals to 1 and lambda is half, I should be in a position to satisfy the third equation, correct? If I am able to satisfy that third equation, then the value is correct, right? So let's check. So we are going to check our result with the third equation. So that is the idea. So let's check. So to check, we'll start with the right side, which is lambda times, so lambda is half, right? So we'll write half times twice 1, so twice times 1 minus 6. That gives us half of minus 4, which is minus 2, which is correct. Perfect. And therefore, we know that it works. Correct? So in this particular case, part B, we found that for same direction, scalar product, our multiplier lambda is equal to half, which is greater than 0, right? Positive, which is positive. Since it is positive, it is in the same direction. Perfect. Now let's look into part C. Part C is are in the opposite direction. Now A and B should be in opposite direction. Now part C clearly is no solution. Reason being that lambda is greater than 0. For opposite direction, that should have been negative, right? For opposite direction, we are looking for a negative value, right? So that is the condition, right? So part C, not possible. Since for opposite direction, the multiple lambda should be less than 0, right? But we know it is greater than 0, right? So it is not possible. Is that clear? So that is how you're going to answer this question. So let's move on and take up question number 4. Question number 4. And I have modified this question, included unit vectors. That will give you more understanding of unit vectors. The question is, for unit vectors A and B, magnitude of A plus B is equal to square root 5 over 2. Find 3A minus B dot A plus B. Now, as you have already seen, that when we talk about magnitude of a vector, then we could write this as dot product, right? So what is A plus B dot A plus B? Can you tell me that? What is A plus B dot A plus B? Well, this is equal to magnitude of A plus B whole square, right? So that is the property of dot product. Now, magnitude is given to us as square root 5 over 2, and therefore square of that should be equal to square root 5 over 2 whole square, right? Now we can actually do the dot product, equate it to 5 over 2. We already know that magnitudes of A and B is 1, right? So we get A dot A, which is magnitude of A square, plus A dot B, plus B dot A, plus magnitude of B square, that is B dot B, should be equal to square is the number itself, 5 over 2. Now we know magnitude of A is 1, so we could write this as 1 plus A dot B is same as B dot A. So let me rewrite this as A dot B times 2, right? So they are same. And what we have here is magnitude of B square, which is also 1. So 1 plus 1 equals to 5 over 2. Now from here, we can find what A dot B is, right? So what we get here is 2 plus 1 plus 1 is 2. 2A dot B is equal to 5 over 2. And therefore, let me write A dot B times 2 first, okay, is equals to 5 over 2 minus 2, which is 5 minus 4 over 2, or half. So from here, we get A dot B as equal to 1 over 4, right, dividing by 2. So let me highlight this. So using this property of dot product, we found what A dot B is. Now we will actually expand this part and calculate. What do we need to find? We need to find what is 3A minus B dot A plus B is, right? This is equal to 3 times magnitude of A square plus 3 times A dot B minus BA. We could write A dot B also since it is commutative, minus magnitude of B square. So that gives us, since magnitude of A is 1, we could write this as 3 plus 3 times A dot B is 1/4, right? So we'll write 1 over 4 here from here, minus A dot B is 1/4 minus 1/4 minus 1. So that gives us 3 minus 1 as 2. And well, you could have done 3 minus 1 as 2. So it is 2 times. So we get plus 2 times 1 over 4. And that is 2 plus half. And that gives you 2 times 2, 4. 4 plus 1, 5. Or let me write 4 plus 1 over 2. Or 5 over 2. So we get this dot product as equal to 5 over 2. So I hope the steps are absolutely clear. So the idea is, from the given magnitude, you can find what A dot B is, and that helps you to find the dot product. So I hope that's absolutely clear, right? So let's move on. Here is question number 5. We are given adjacent sides of parallelogram are vector A, which is 6, 1, vector B, which is minus 1, 3. Determine the angle between the diagonals. So let me make a rough sketch to begin with. 6, 1 will be somewhere on this side. Let's say, okay, so what we will do here is, well, because 2 dimension, we can make a Cartesian plane here and then sketch. 6, 1, 6 and 1 will be somewhere here. So position vector could be like this. Minus 1, 3 means minus 1, 3. Say something like this. Is it okay? So that becomes B for us. So we have A and B. And this position here is minus 1, 3. We are going from origin. These are the position vectors. And this is 6, 1. Now, how do you find the other coordinates? We need to find one more, right? So we can just complete this parallelogram. And as you can see from here, from 0, 0, we have to go minus 1, 3. So that means we'll do minus 1 of 6. 6 minus 1. And 0 to 3 means add 3. So we'll do 1 plus 3 to get this coordinate. So we get, basically, we get this coordinate C position C as 6 minus 1 is 5, 5, 4. Correct? So that becomes the coordinates of point C. Now we need to determine the angle between the diagonals. Now what are the diagonals? Let's say this point is O for us. So diagonal OC is the vector 5, 4. It is from the origin. How about, let's call this point as A and this point as B. So diagonal BA is what? What is BA equals to? BA is 6 minus minus 1, 6 minus minus 1, and y value is 1 minus 3, 1 minus 3, which is 7, and 1 minus 3 is minus 2. Is it clear? So these are the two diagonals with which we have to work. And we need to find angle between these two diagonals. So the diagonals are BA and OC. Now the angle between them is, let's say this angle is theta. The other angle is a supplementary angle, right? Now let's find the angle theta first. So we can find this angle using dot product. So what is OC dot BA equals to? That is magnitude of OC times magnitude of BA times cos of theta. So cos of theta can be written as equal to dot product of OC and BA divided by the magnitude of these two diagonals vectors, right? So cos theta is equal to OC is 5, 4. So we can write this as 5, 4 dot BA 7 minus 2. And magnitude will be 5 square plus 4 square for OC times magnitude of BA is 7 square plus minus 2 square. Correct? Now that gives us 5 times 7 is 35, 4 times minus 2 is minus 8 divided by square root of 25 plus 16 times 49 plus 4. And that gives you, let's use calculator now, right? Those square root terms we'll have to find. So we have 35 minus 8, which is equals to 27, over square root of, this is 25 plus 16, okay, so 25 plus 16 is equals to 41 times square root of 53. Right? Now, from here we can get the angle theta as equals to cos inverse of this number, 27 over square root of 41 times 53, which is, let's calculate. So we'll do shift cos inverse, within bracket we have 27 divided by square root of 41 times 53, bracket close, equals to, so you get 54.6 degrees. So that's the angle theta which we get, right? Now, as you can see, always there will be a supplementary angle phi. So we could write this as acute angle is 54.3 and phi, the other angle will be 180 degrees minus 54.6, which is 180 minus 54.6 equals to, in decimals, 125.4 degrees, right? So that becomes the answer. So the angle between the diagonals are 54.6 degrees and 125.4 degrees, right? So that is how it can be answered. So let's move on and do question number 6 now. Question number 6. Find a unit vector perpendicular to vectors A 3 minus 2 7 and B 2 minus 1 2. It is important to note that we could have many vectors perpendicular to a set of vectors, right? Now let us see how to use dot product to find perpendicular vectors. So that is an application of dot product. So let us say that let a vector P, which is in general x, y, z, is perpendicular to both A and B. Okay. So in that case, their dot product should be 0, right? So in that case, 3 minus 2 7 dot x, y, z should be equal to 0. So if I multiply, I get 3x minus 2y plus 7z equals to 0. So that gives me one equation. So let me call this as equation 1. Now, it is also perpendicular to 2 minus 1, 2. So, 2 minus 1, 2 dot x, y, z should be equal to 0. That gives you another equation, which is 2x minus y plus 2z equals to 0. So we get two equations. We have three unknowns. Do you see that? So we have two equations with three unknowns, x, y, z. Well, let's simplify. We can multiply equation 2 by 2. So if I do that, that is to say, I will do 2 times equation 2. In that case, what do I get? I get 4x minus 2y plus 4z equals to 0. So let me call this as our equation 3. So if you look at equation 1 and 3, we have made the coefficients of y same, right? So if I do equation 1, take away equation 3, then 3x minus 4x gives us minus x, minus 2y is 0, 7 minus 4 is 3, so we get plus 3z equals to 0, right? Now taking x to one side, or we can say that x is equals to 3z. So we get x in terms of z. Now in such cases, we can use a parameter. So we'll say let z equals to t. Now if z equals to t, then x is equals to 3t. Do you see that? So we used a parameter to further simplify. Now, using equation 1, which is for us 3x minus 2y plus 7z equals to 0, and we know x is equals to 3t and z is equals to t. We can substitute, right? So what we get here is 3 times 3t minus 2 times y plus 7 times t equals to 0. We can find y in terms of t. So taking this to the right side, we get 6t plus 7t. I'm sorry, 90. 3 times 3 is 9. 9t plus 7t is equals to 2y. 9 plus 7 is 16. So 16t equals to 2y. Or that gives us y is equals to 16t over 2, which is 8t, right? So we get x as 3t, we substituted z as t, and now we get y as 8t. So x, y, z are known, so we can say the vector p is 3t, 8t, So that becomes the vector. Now the question is, now we could give any value to t. We could give it t as 1 also, right? So we could give t as 1. So if t equals to 1, we do get a vector which is 3, 8 and 1, right? But the question here is, you need to find a unit vector perpendicular. Now this magnitude is not 1. To make it 1, what do we get? So the unit vector will be, you have to divide this vector by its own magnitude. Is it okay? To get unit vector. So what we get here is 3, 8, 1 divided by the magnitude, which is 3 square plus 8 square plus 1. And that gives you 3, 8, 1 divided by, let's add this, 9 plus 64 plus 1, so 10, 74, right? So the vector will be given to us as 3 over square root of 74. Let me rewrite this somewhere. Okay, let me just push this here. So we get here that P, unit vector P is 3 over square root of 74, 8 over square root of 74, and 1 over square root of 74, correct? So that becomes the unit vector. Perfect. So our answer, let me write here, answer is answer will be 3 over square root 74, 8 over square root 74, and 1 over square root 74. So that is the unit vector which is going to be perpendicular to both the given vectors. We are at the end of this video. The last question, question number 7 is, the rectangle ABCD has vertices A minus 1, 2, 3, B 2, 6, minus 9, and D 3, Q 8. Determine angle between two diagonals. Now this is a very interesting question. We are given the vertices, not the vectors, okay? So let me just make a rectangle here. Always write in a particular order, in any order, right? If you want to write A here, begin with A, B, C and D, right? So it becomes like this. So in particular order. You could go clockwise or counterclockwise. Now what we are given here is that coordinates for point A are minus 1, 2, 3. For B, it is 2, 6, minus 9. For C, we don't know. And for D, we know it is 3. Q is not known. And 8. We have to find what C is. Now there are a couple of ways to do it. Easiest way is, we can say that these two sides are equal and they are 90 degrees. Perfect. So we know that A to D is same as B to C, right? So we know AD is same as BC. Now if you see A to D, AD basically is, how do you get 3 from minus 1? You add 4, right? So if you see A to D, it is this minus this. A to D is this minus this, which is 4. Q minus 2. And 8 minus 3, which is 5. Now C we don't know, so we'll write this as X, Y, Z. Is okay? So it is equal to X minus 2, Y minus 6, and Z minus 9, which becomes minus and minus is plus. So from here clearly we get 3 different equations, and so we can find X, Y, and Z. So the first one is X minus 2 equals to 4, which is 4 equals to X minus 2, or 6 is equals to x. So we get the x value, right? Then we have q minus 2 equals to y minus 6. So we actually get y in terms of q. Taking 6 to this side, we get q plus 4 equals to y. The last one here is 5 equals to z plus 9. Or when you take away 9 from 5, you get minus 4 equals to z. So the coordinates for point C basically are 6. And in terms of q, we have q plus 4 and we have minus 4. Right? Now that's the trick part. How do we find q? How do we find q? Now to find q, the dot product between AB and AD is 0, right? So to find q, what we are going to use is that AD dot AB equals to 0. That is what we are going to use. We could have done this initially and then this exercise. It was better. Now let's do it. So AD is 4, q minus 2 and 5 dot A to B is 2 minus this, we get 3. 6 minus 2, we get 4. Minus 9 minus 3 is minus 12. And that should be equal to 0. So let's multiply. 4 times 3 is 12 plus 4q minus 8 minus 12 times 5 is 60 equals to 0. So we can calculate q now. So 4q is equal to, let's do this. So we'll do 12 minus 8 minus 60, which is minus 56. Taking it to the right side, we get plus 56. So this gives you q as equals to 56 by 4. So 56 by 4 is 14, right? 14. Perfect. So we get a value of q. Since we know now q is 14, let me rewrite this as 3, 14 and 8. And q is 14, so this means c is equal to 6. 14 plus 4 is 18 minus 4. So we know c now. Since we know c, we can now find the diagonals and the angle between them. So diagonal AC, what is AC equals to now? So diagonal AC is c is 6, 18 minus 4. So diagonal AC is A is this, 6 minus minus becomes 1, 18 minus 2, minus 4, minus 3. That is AC. So AC is 7, 16, minus 7. That is AC. Let's find what BD is. Okay, so we can write DB as you wish. We can write DB. DB is 2 minus 3, which is minus 1, 6 minus 14, which is minus 8, and minus 9 minus 8, which is minus 70. So that becomes dB, right? This becomes this. Now to find the angle between them, that is to say, now we have this diagonal. That is the angle theta we want, right? So the angle cos theta is equal to dot product of these two. So let me write 7, 16 minus 7 dot minus 1 minus 8 minus 17 divided by magnitude of these, which is 7 square plus 16 square plus minus 7 square times 1, let me write 1, 64 and 17 square 289. Correct? So that becomes the cos theta part. So let's do the dot product now. 7 minus 7 we get 16 times 8 with a negative sign. 16 times 8 is equals to 128. And then we get plus 7 times 17. 119 divided by square root of 7 square plus 16 square plus 7 square is equal to square root of 354 times square root of 1 plus 64, 1 plus 64 plus 17 square is 289 equals to again 354, right? So that is 354. Now this is equal to, we're going to 119 take away 7 take away 128 is equals to minus 16 divided by 354, right? So we have 16 divided by 354, which is 8 over 177 anyway. So we can find theta from here. Now since this is negative, we are actually finding this angle for negative, right? Obtuse angle. So let me write the acute angle first, which will be kind of positive, because both are the right answers, right? So what we can do here is we can find theta as cos inverse of 16 over 354. So we get shift cos inverse of 16 divided by 354, which is equal to 87.4, right? So that becomes the acute angle. The other angle is 180, I'm sorry. The other angle is 180 minus 87.4, which in decimals is 92.6. So we can say the other angle, let's call this as phi, is equal to 92.6. So these are the two answers for the given question. So I hope you have learned about dot products in this particular video. Feel free to write your comments, share your views, and if you like and subscribe my videos, that'll be great. Thanks for watching and all the best.